Hello my dear students of class 10 and 12. This is the common topic resistance. Today I am going to explain you about resistance. What do you mean by resistance? ऐसे भी इसका वर्ड मीनिंग भी होता है बाधा, ऑब्स्टेकल. During flow of charge, flow of electricity, flow of current through the conductor, we are saying that this is conductor. Conductor means what? Which allow the charge to pass through it. क्या ये 100% चार्ज को पास होने देता है? क्या ये कोई भी ऑपोजिशन नहीं ऑफर करता है? करता है. Its passing quality is 60%, then it is conductor. If the conductor has passing quality 49%, it will become it will become bad conductor, not insulator, bad conductor. So conductor and bad conductor, the conductivity is only difference between the conductivity is 2%. 49% is conducting property, it is poor conductor. 51% conducting activity, then it is conductor. So 49% also that obstacle is produced by the conductor. So resistance is nothing, it is the opposition offered. Opposition offered by any conductor during flow of charge. You may say flow of charge, flow of electricity, flow of current is called resistance. So we have derived the formula for the resistance in the previous video, where the determination of Ohm's law is there. Ohm's law is determined for class 12. That video is fruitful here. So resistance is denoted by R and is given by rho L by A. So R is resistance of conductor, rho is resistivity of conductor, L is length of conductor, A is area of cross section of conductor. So this is the formula from where we can calculate the resistance of any conductor. So its unit, SI unit, is ohm, or here we can write it is ohm. Now what is the factors on which resistance of a conductor depends? What are the factors? There are many factors. Number one, length of conductor. From this formula it is clear, if you take area of cross section and rho constant, what will happen? Resistance is directly proportional to length. जितना लंबा होगा उतना रेजिस्टेंस ज़्यादा होगा. कंडक्टर लंबी होगी तो रेजिस्टेंस ज़्यादा होगा, कंडक्टर छोटी होगी तो रेजिस्टेंस कम होगा. keeping area of cross section and resistivity same. You should not change the material, you should not change the area of cross section, then resistance will depend on length of the conductor. So first factor is length, second factor is area of cross section. R is inversely proportional to area of cross section. Means if the conductor is thick, the resistance will be, conductor is thick, area of cross section is larger, resistance will be smaller. If the wire conductor is thin, its resistance will be more. अगर ऐसा क्वेश्चन है कि there is a conductor of same length and same material, one is of 2 meter square area and other is 1 meter square area, whose resistance will be more? The 1 meter cross sectional area, 1 meter square, have the more resistance because it is thin, and thick has less. Now number 3 is nature of conductor. Means resistivity. What will happen if we compare the resistance of copper with aluminum or copper with silver of the same length, same area of cross section? Resistance of copper will be different than resistance of silver. Resistance of copper of the same length and area of cross section to the silver is more than that, than the silver. So nature of conductor is also important. Number 4, it is temperature. Temperature of conductor. Temperature of conductor. So the resistance of the conductor will increase with the help of resistance increases with increase in temperature of conductor. Temperature of conductor means R is directly proportional to square root of temperature. It is conclusion, even it is increases. As we have R is equal to rho L by A, it will not change with the temperature, but length and area of cross section may change with change in temperature. As you have learned that there is linear expansion, there is a superficial expansion, there is surface expansion. So there will be expansion in the size of the conductor due to change in the temperature. So resistance also changes, and resistance of the conductor at any T temperature is given by R naught plus alpha R naught T and plus so on. So it is changing with the temperature also. Alpha is the temperature coefficient of the material. So it is the factor which affects the resistance. Temperature, with increase in temperature, resistance of any conductor increases. I will explain it in detail in the next video. So this is the factor. Now come to the resistivity. Resistivity is nothing, it is the resistance of a conductor of unit length and unit area of cross section. This is resistivity. Resistivity is nothing, it is the resistance of a conductor having its unit dimension, unit length and unit area of cross section. If the material is not changing, material remains fixed, then the resistivity is the resistance of a conductor of unit dimension. So here R is equal to rho L by A, L is equal to 1, A is equal to 1, then what will happen? R is equal to rho. R is equal to rho. So resistivity is numerically equal to resistance of the conductor having unit length and unit area of cross section. So what are the factors affecting resistivity? Resistivity rho does not depend on length and area of cross section. It is unit. My dear student, always remember, with change in length and area of cross section, resistivity of the conductor will not depend. It will change only with the change in material. So number one, it will depend on nature of material, and number two, temperature of conductor, not material, conductor. Material of conductor. Only this thing. Resistivity also, rho also changes with temperature, square root of temperature. It is different for different material. Conductor, insulator and semiconductors are there. So it will also change. It depends on temperature. It does not depend. It does not depend upon length and area of cross section of the conductor. Mind it. It never depends. What will be the unit? What will be the unit of resistivity? From here you can calculate. R has O, resistivity निकालना है, meter by meter square. So it will be cut. Length has meter and it has meter square. So what will happen? Rho is equal to ohm meter. This is the unit. SI unit of resistivity is ohm meter. This is all about resistivity. Thank you.